And all right, we're going to treat this as class friends. So Aiden, since you request this, you get to read it out loud.
Draw a triangle RST is an isosceles triangle with S as a vertex. Triangle RTW is adjacent to triangle RST, where angle SRW is a right angle. Triangle RTW is also an isosceles with a vertex T. The measure of angle RST is 3 times the measure of angle RTS. With the given circumstances, find all possible angle measures.
Okay. Jesse, thanks for joining us. Let me just keep track of who's here. We are going to do problems 1, 2, 4, and 9, and then we'll go from there. So step number 1, all I want you to do is draw just that. We'll take this one step at a time. So I'll give you 30 seconds to draw each of these steps. Make sure you're working in pencil so that if you make a mistake, you can erase it. TJ, pipe up here. Join us. Which letter should be at the top of this triangle and why?
S.
Correct. Can you tell us why?
I don't know.
Okay, well, you're correct. S is the what, TJ?
Vertex.
Vertex. And so S has to be the hinge between the two equal sides. So that's why S has to be the hinge. So S has to be at the top. These two sides are equal. It doesn't matter which one's R and which one's T. So just for giggles, I'm going to make this R and this T. Okay, next line. Ethan, can you read this blue line for us, please?
RTW is adjacent to RST, where angle SRW is a right angle.
Okay, real quick here. Charlotte, are you there, ma'am? Look really carefully. This question's from Charlotte. Charlotte, what 2 letters are repeated there? Okay, so it's not Charlotte's on. Let's see. Who else can I pester? Ayush, what 2 letters are repeated?
RT.
Yeah, R and T. That means RT is the backbone between those 2 triangles. And then, so that means W is around here somewhere. We don't know exactly where, but since R and T, that means W is here. And very important, it says SRW. If you trace it, SR to W, that is a 90-degree angle. Now
So
we
Ms.
have
Wei,
yeah, what's up, Aiden?
do we not make TRW a triangle?
Yes, we're going to. I'm just
okay.
emphasizing the fact that that's a right angle. So yes, you can make that a
Okay.
triangle, absolutely. All right, next one, this next sentence. Let's have Kylie, can you read that next sentence, ma'am?
RTW is also isosceles with vertex T.
Okay, I'm going to wait 30 seconds to see if you guys can mark that accurately. It's just that orange. Okay, check your work here, friends. Watch carefully. It says T is the vertex in this triangle. That means T is the hinge between your two equal sides. So your two equal sides are here and here. And if you have two equal sides, that automatically means you have two equal angles. Two equal sides, two equal angles. Next, we have this in yellow. So, Anik, can you read the yellow out loud?
The measure of angle RST is 3 times the measure of angle RTS.
Okay, I'm going to let you guys mark that on the diagram. I'll give you 30 seconds. Okay, it says right here that RST, if you trace it, here's R, here's S, here's T. See that little dot up there? That means this is 3 times, that means it's a 3x of RTS. RTS, see the little dot there? If that's 3x, this is x. But what's important here is if you have two equal sides, you have two equal angles. So if this is x, this is also x. So Jesse, how are we going to solve for x here, sir?
Sorry, what?
How are we going to solve for x?
Since x plus 3x equals 180, then you just go by that.
Yes, x plus 3x equals 180, and you go from there. That will start getting you angles, folks. And once you get one of those angles, you should easily be able to get everything else. So I'm not going to do that math for you. You can do it on your own and then check your work in class. So I'm going to move on to the next problem. I think the next one that seemed to get multiple votes was this problem right here. And we're going to need a straight edge. So I'll get my straight edge handy. Okay, one step at a time. Kylie, can you read bullet number 1, please, ma'am?
Draw triangle HIJ as an obtuse isosceles triangle with H as the vertex.
Okay, that means H has to be the hinge between the two equal sides. And it doesn't matter which one's I and which one's J. I'm just going to go clockwise here, I and J. Okay, second bullet. All right, Rajani, can you read the second bullet for us, please?
Mark P is the midpoint of HI, Q is the midpoint of IJ, and R is the midpoint of JH. Draw in the midsegments PR, RQ, and QP.
Okay, so P is the midpoint of HI. So there's P. I come around here. Midpoint of JI, is that Q? Friends, double check since I lost it. Is Q the midpoint of JI or JH?
JI.
JI. Okay, so this is Q. Technically, whoops, that should be 1 and then 2. Hang on. This was our first one. This is our second one. And just confirming here, folks, this is R, correct?
Yes.
Okay, and that's our third one. Now we're going to connect these mid segments. There's one. There's two. There's three. I'm going to color code these real quick. Watch very carefully what I'm doing. Okay, these inner ones, those are called mid segments. Why? Because they connect the midpoints. Okay, next bullet. All right, good morning, afternoon. Hi, London, we're on problem number 2, ma'am. London, we're on problem number 2. Ayush, can you read the third bullet for us, please?
Okay. Draw JH, extend to make an exterior angle, sweep counterclockwise, extend HI, sweep an exterior angle, sweep counterclockwise, trace and extend IJ, sweep exterior angle counterclockwise.
Okay, so we're going like this. Notice the ray says JH. That means endpoint J, extend through H, endpoint I, extend through H, extend through I, endpoint I, extend through J. And then you sweep these external angles because you're going to want to find those. The last bullet there, the last bullet.
Miss Way,
Yeah,
in the problem, it says like sweep it counterclockwise. What does that mean? Like, does that mean
okay,
anything?
hang on. Did I get that? Did I get that wrong? JH. JH. Yeah, counter like this.
Oh, so it just means like the
Yeah,
outsides.
yeah.
Okay,
like-
I thought it was like you had to do a specific way.
No, it just means the
Okay.
outside. Got it. Charlotte, the last bullet, ma'am. Charlotte, not there? Okay. Ethan, the last bullet, sir.
HJ equals 36, QJ equals 20, and the measure angle JHI equals 104.
Okay, so this is 36. And this up here is 104 degrees. And what am I missing? Is it QI or QJ?
QJ equals 20.
Okay, good. Be 20 units, not degrees. I think there was one more thing. Did I tell you this is isosceles to begin with? Yes. Isosceles. So you need to realize that these two sides are congruent, these orange sides. All right, friends, I'm going to give you 2 minutes, and I really want you to work on your own. 2 minutes, find everything possible before we move along, because I don't want you just copying answers. I'm going to even set the timer so that you know you're not my hostage longer than 2 minutes. So 2 minutes, find everything you can. I'm going to go nuke my cup of tea. I'll be right back. Okay, let's see how you did here. All right, so what you should have remembered is this is a 1 bunny hop and a 2 bunny hop relationship. It's a 1 to 2 scenario. So let's do the side links lickety split. Let's see. Anik, what would be JI, the length of JI?
40. It would be 40.
Yeah, that would be 40, of course. And that would be 20. And then, guys, what you need to realize is that these are parallel, so that would make this 20 as well. It's a 2-to-1 ratio. Now I'm only going to get you, you could easily get all the side lengths from that. The tricky part is the angles. So very simple. You see these red angles? I want everyone to text me what would be the measure of those red angles. Okay. Thanks, Ayush. Appreciate that. Thank you, Anik. Charlotte, let's chat. Charlotte, can you unmute real quick?
Yeah.
All right. What's true about these 2 red angles? If this is an isosceles triangle, what's one thing that's true about those red angles?
They're congruent.
They are. So let's say if this is X, what would this be also be?
X.
X. So I know X plus this angle up here, 104, would have to equal how much, ma'am?
180.
All right. Do you see where you want to go there?
Yeah.
Okay. I'm only going to give you one little shove in the right direction, guys, and then you have to finish on your own. 2 things you want to watch out for. Put this in the margin. If you have parallel lines, you want to watch out for 2 different kinds of angles. 1, corresponding angles. They are congruent. I'm going to highlight a pair of green corresponding angles. That would be one. That would be another. Then you also want to watch out for parallel lines. You also want to watch out for armpits of the Z, also known as alternate interior angles. And that would be like these 2 angles right here. Armpits of the Z. Those are congruent as well, when lines are parallel. So with that information, you can find the rest of the angles. I'm not going to do it for you because the answer key will be in class. Okay, the next vote seems to be number 4. Number 4. Who requested number 4? Just send me a chat real quick. Say you requested. Requestion. Yikes. Speak up, kiddos. Who requested number 4?
I did.
You did. Okay. Oh, Isaac, this is the one you, okay. Isaac, go ahead and read the given information for us.
Okay, we are given that triangle BAC is isosceles with A being the vertex, and and angle BDC is equal to the angle CEB.
Okay. We're going to mark ourselves through given. So we're given that this triangle BAC is isosceles with A as the vertex. And we're also given that these two angles BDC, if you trace it, BDC is congruent to CEB. So that is our given. London, can you read? What are we trying to prove here?
That DC is congruent to EB.
Okay, I'm going to squiggle that, not hatch mark it, because it's what we're going to try to prove. We're going to try to prove that these two segments are of, I'm just going to go like this with them, of equal length. Now, I give you a hint. I give you a hint here. Let's have Anik. Can you read the hint, please? Did Anik leave us? All right, Kylie, can you read the hint, please, ma'am?
Trace and pull apart triangle DBC and triangle ECB. Show triangle DBC is congruent to triangle ECB first.
Okay, so DBC is this triangle here. We're going to trace and we're going to pull that apart right here. And then the other triangle, CEB, is this one overlapping. And the reason why we're choosing these two triangles, BDC and CEB, is because the two segments that we want, which are these two, are part of those two triangles exclusively. That's what we're trying to connect. Now I'm going to carry over what we already know to be true. We already know that angle D is congruent to angle E. That gives us an angle. Given, implied, freebies, talk it through. So we are done with our given. I want you guys to text me what else is implied. What else do you know to be true, and what might be a freebie? What else is implied and a freebie? Text it to me, whatever you think. It's okay to be wrong here. Yes, Ayush. Rajani, you are correct. There's vertical angles, but the vertical angles disappear. All right. Charlotte, you're correct. Yes, Aiden, there are bow ties. Okay, Ayush, we can't say that DB and EC are equal yet. Kylie, you're correct. All right, so there's two things a lot of you guys notice. Ooh, Isaac, Can you unmute and explain which two angles are congruent and why? That you just said.
Yeah, I said that angle DBC and ECB were congruent because they said that BAC was isosceles with A as the vertex. So
Correct.
if it's isosceles, the base two angles will be equal to each other.
So I just did the pullout. What Isaac said, if you have two equal sides, you have two equal angles. So you are totally correct. I'm going to squiggle them in green. We know this angle and this angle are congruent. And the reason we know that is because of the isosceles triangle information. Then, Charlotte, you gave me a freebie. And also Kylie did as well. So Charlotte, what was the freebie?
BC is a reflexive side.
Mm-hmm. BC is shared by both. It's the exact same thing for both. So hatch mark, hatch mark. All right. Aiden and Rajani, the reason why, even though you have vertical angles here, do you see that when you pull the triangles apart, those vertical angles disappear?
Yeah.
Okay.
Yes.
All right. Ready, folks? When I pause, let's have a little fun here. See if we can do this all together. Unmute, get ready to talk. When I pause, you say angles or sides. Right here, we have a pair of
Angles.
Angles.
Right here, we have another pair of,
Angles.
and then we have a pair of.
Sides.
Sides.
Lovely. You guys got it. So our shortcut is going to be angle, angle, side. Now those three steps gets you congruent triangles. And then after you get congruent triangles, your very last step is going to be these sides are equal. Because if the whole is equal, the parts are equal. So I'm just going to number them for you. I'm not going to write this out. So these pair of angles would be step 1, step 2, and step 3 is this angle that takes 2 steps because you first have to mention the isosceles before you can say the angle. That is going to be step 4, step or box if you're doing a web, and you would write it like this. BC is congruent to BC because it's reflexive. Step 5, you have to specifically name the triangles that are congruent, which you have right up here. And the reason would be, of course, angle, angle, side. And then step 6 would be the parts are congruent, which is your target. Okay, I'm not going to write it for you because you all have different styles. Some of you might want to do a 2-column where the how goes on the left and the why goes on the right. Some of you might want to do a web where you start with a couple pieces of information from your given and you show how things fit together. And then some of you are like, Ms. Way, just leave me alone and let me write a paragraph. And that's perfectly fine too. Questions?
Yeah. So for the second angle, DBC equals ECB. Would that be that's not given. That would be like that's implied, right?
It is
How would
implied,
the-
but you have to be specific. It's implied because of 2 equal sides, 2 equal angles.
Oh, okay. Thank you.
Yeah, 2 equal sides, 2 equal angles. So that's either 6 sentences, 6 boxes in a web, or 6 steps in a 2-column. All right, whoever answers that next question next gets dibs on the next question. All right, Rajani, you answered first. Kylie, we'll come back to 5 in a moment. Okay, students, question number 7 and 8 are constructions, and there's a separate video for that because I had to use my document camera for it. All right. Number nine, let's do this one step at a time. Rajani, can you read that first bullet out loud?
Triangle FGH and triangle FQH are adjacent triangles.
And then Rajani, read the second bullet as well.
Draw an obtuse triangle FGH with G as the obtuse angle.
Okay, so that gives us a heads up that this one angle right there at G has to be obtuse. Now look really carefully. Someone else besides Ranjani, actually, I want everyone to text me here. Which letters between these two triangles, which letters are repeated? I'd like you to text it back to me. There's 2 letters, friends, careful. Which letters? Rajani, Charlotte, you got it. Aiden, you're good. Yes. Just to make sure. Gotcha, London. Okay, so F and H have to be the shared side. And then we have Q and G. So I'm going to start with the shared side right down the middle, which has to be F and H. And then Ranjani made a special notation that G here is obtuse. So that means when I draw this triangle, G has to be an angle that looks bigger than 90 degrees. Let's see if there's any other information. Adjacent, obtuse. All right, that's all you know so far. And I'm just going to write the word obtuse. And then we have this other letter Q. We don't know anything else about this triangle, except Q is over here somewhere. We don't know if it's obtuse or what else is going on. We just know it's Q. All right. Next one, out loud. Isaac, can you read that green for us?
Angle GFH and HFQ are complementary.
Okay. Complementary means 2 angles that sum 90 degrees. It doesn't mean they're 45, 45. It just means whatever they're at, they're 90 degrees. I'm going to give you about 30 seconds to draw that on your own, and then I'll go over it real quick. Okay, it says GFH and HFQ. So GFH and HFQ are complementary. That means them together must equal 90 degrees. All right, our next bullet.
Wait, can you go back to the diagram for a second?
Yeah. GFH and HFQ add up to 90. Now, it doesn't mean that's bisected. It just means whatever it is, it adds up to 90.
Thank you.
Okay. All right. Next bullet, Aiden, can you read the next one, please, sir?
Sorry, okay, it's the blue one, right?
Blue, yes.
All right. Triangle FGH and triangle FQH are adjacent. FQH is a right triangle and angle Q is a right angle.
Okay, I'm gonna give you 30 seconds to draw that. So now we know a little bit more about this triangle here. It is a right triangle at Q. So even if you don't have it drawn accurately, that should be a right angle. And our last bullet, Ethan, can you read that last bullet?
The measure angle HFQ is 5 times the measure of angle FHQ. Draw the description to scale.
Okay, I'm gonna let you guys, I'll give you about 30 seconds to try to draw that on your own. Okay, whenever something's 5 times something else, that means we have a 5x to x relationship. We have a 5x and x relationship. We're on problem number 9 for those who just joined us. It looks like Jesse. So it says HFQ. That's this one, HFQ. This is a 5x to FHQ X relationship. All right, so I'm going to send something in the chat. Make sure you guys respond to it. I want you guys to send me some algebra. Go. Text it back to me. Isaac, you're correct. Aiden, you're good. Charlotte, you're good. Johnny, fine. You took a shortcut. I'll let it ride. Ayush, good. London, okay, almost. London, do you see that you have an X and a 5X? London, what's your third angle? Okay, you have an X, you have a 5X. What's your third angle?
Oh, 90 degrees.
90. Okay, good. I've got 2 more of you. Send me a text. How would you solve for X there? Text it to me. So you're supposed to find everything in the diagram, and just a subtle hint, guys. Just because I tell you to find everything possible doesn't mean everything is possible. There may be angles you're not able to find, but that's for you to figure out.
That's gonna drive me crazy on the test.
I know. Kind of my point there, Isaac. Kind of my point. You have to find your own boundaries.
This way.
Yeah, London.
On the test, is it just like you write the question and then like do the oral exam part, or is there 2 parts to the
There's going to be 2 parts. You're going to get two oral exam questions. So, and you'll have to do both of them.
Questions?
There'll be 2 questions, yes.
So it's just those 2, and then the test is done?
No, sweetheart. I mean, they will be questions similar to the key questions, but not exactly the same. So about half of these are proofs. And then the other half are like words to drawing translation. And then that's like 3 of them are word to drawing translation. And then 2 of them are related to angle bisectors, medians, altitudes, and constructions and drawings and that kind of stuff.
Wait, Miss Wade.
Yeah. Hi, what's
on
up?
the test, are you gonna have the constructing problems, and also graphing problems?
You will have graphing problems and you will potentially have construction problems. Yes, so you need to know your constructions. There's 4 of them.
Okay, because I was a bit confused, because I don't know how you do a construction on like a whiteboard.
I may require you to do it on paper and then on the whiteboard, you can just draw it.
Okay.
Guys, the constructions, if you go on my YouTube channel, just do Kelly Way YouTube, you will see 2 videos. One's called the Unit 3 constructions. That will be specifically questions 7 and 8. And then there's the reference booklet constructions, which are the constructions in your reference booklet, which will show all 4. But how about this? I know some of you, it's not the constructions that bothers you, it's finding all the angles. So if you want, we can I can do another question, but how about this? Who would like help with question 7? Or question 8, which we'll do, I'll come up with a way to do one of those. Which one would you like to go over? Send me a chat, friends. Okay, so this is what I'm going to do. All righty, guys. Those of you who want help with 7, you're going to toggle to my YouTube. Let me show you. Is my screen still on? Yeah. Got it. Kelly Way YouTube. And what I'd like you to do is just watch the first about 5 minutes of the video. Thank you, Aiden. Appreciate it. So that you get the constructions. There's 3 constructions. And then Kylie or whoever else wants to come back, then in approximately, I'll say about 6 to 7 minutes after you've done just the constructions, then I'll go over some of the angles. How does that sound? But I'm not good. I can't redo the constructions because I don't have my document camera with me. Okay. Do the first 6 to 7, about 5 to 6 minutes, just the constructions for 7, and then return. Text me when you come back, and then I'll go over the angles. Okay. In the meantime, those of you who don't want the constructions, why don't you text me another problem you'd like to go over that's not the constructions? Okay, London, you're not using an equation for median and altitude, you're using a construction. So London, can you see my screen right now?
Yeah, but I'm not talking about that question.
which which one are you on, sweetheart?
Question 10.
10. Oh, let's do that one. That's a good one. That's a good one. So while we're waiting for the constructions, you and I will do 10. Okay, who else besides London is going to track with 10 with me? All right. Looks like it might just be you and I for this, London. That's perfectly fine. Go ahead and read the given, London.
Triangle ABC with A at points -2 and 3, B at -5 and -4, and C at 2 and -1.
Okay, so here we have A, B, and C. Go ahead and connect to make a triangle. All right, London, go ahead and read what you're trying to prove.
Prove that triangle ABC is an isosceles triangle with B as the vertex, and that the median drawn from vertex B is also an altitude.
Okay, so there's technically 3 different things we're proving. Let me circle them. 1, 2, 3. And I'm going to draw 3 little baby triangles down here so that you can kind of get all 3. And if you notice, I'm color coding them. All right. So see those 3 little triangles? Okay, London, step number 1. What is true about that statement? What would be true?
That 2 of the sides have to be congruent.
You are correct. With what as the vertex?
B.
Okay, so going down to your little baby triangles, do you see it would have to be these 2 sides that would have to be congruent?
Yes.
Got it. Okay, so that's one thing you have to prove. What's the second thing you need to prove?
That the median drawn from vertex B is also an altitude.
Okay, so London, question, what's a median?
I forgot.
Okay, I totally understand that. Do you happen to have your Unit 3 preview notes?
Yeah, I'll have to find them real quick though.
Yeah, why don't you do that and everyone else do that? You're looking for Unit 3 and specifically preview video 3.3. So if you can look that up, I just had someone join and let me figure out who just joined. Hi, Darcy. TJ, I haven't heard from you at all. Are we working on problems that you are finding helpful?
Yeah.
Okay. Ethan, are we working on problems you're finding? Are you doing the constructions?
I'm doing number 10 with you guys.
That's fine. So Ethan, why don't you also look up what is a median and what is an altitude?
Miss Way, I think I found it.
Okay, define median.
The median
Define
connects
altitude.
the vertex to the midpoint.
That would be a median. So watch. So from B, look at our little baby sketch. Vertex to, and then we have to find the midpoint. That would be a median. Do you see what I'm doing here?
Yes.
Got it. And then what's an altitude, ma'am?
It connects the vertex to something, but I'm not really sure.
Vertex to a right angle.
Okay.
That's an altitude. Vertex to opposite right angle side. Altitude. So it's really important you know the difference between a median and an altitude. I'm going to type it in the message. Median connects triangle vertex to opposite midpoint. And an altitude connects vertex to right angle opposite side. All right, so one thing at a time. Ethan, I'm coming to you now. Ethan, if I wanted to prove that these two side lengths are equal, would I use midpoint, slope, or distance?
Oh, distance.
You are correct. You're correct. So you're going to find the distance of BA and the distance of BC. Let me give you your distance templates. You should be in the habit of doing templates. You put your coordinates in there and find those distances. Text me when you're done.
Okay, I finished.
All right. What'd you get?
I got 58 for BA and BC.
Yeah, except it's root 58.
Or yeah, root 58.
Root 58. Okay. So London, are you getting root 58?
Yeah.
Okay. So London, explain, what did this math just prove?
That the distance from BA and BC are the same.
Correct, which proves it's a what?
It's an isosceles triangle.
Yes. Yes. Okay, so Ethan and London, I'm not going to do this entire problem, but I walk you through the next two by telling you what to do. The midpoint template, add the x's, divide by 2, add the y's, divide by 2, slope template, y over y, x over x, y over y, x over x. So you're going to do your math for all three of those, and then you're going to summarize, or you can wait to summarize tomorrow if you'd like. How does your math prove all three of these? 1, 2, 3. All right, Kylie, you back, ma'am?
Wait, Miss Way, I have one question.
Yes, London.
To prove that it's an altitude,
Mhm.
how would I basically explain that?
Okay, so right here, what do I ask you to find?
Slope
Of,
of AC and BQ.
okay, so you're gonna find point Q in this step. And what you're basically finding is that Q is gonna be this midpoint here, which proves that B to Q is a median. Then you find the slope of BQ and the slope of AC, and your math should prove what is right here.
A right angle.
Good. And how do we get that in the margin? That's perpendicular lines. This is going to be true. Slope times slope, whatever those slopes are, they have to multiply to -1. What's the property, London, of perpendicular lines?
Slope times slope equals -1.
Yeah, in other words, they're opposite reciprocals.
Okay.
So for example, if one of your slopes is 3/4, your other slope would be -4/3. And that would multiply to -1. That would tell you that you have perpendicular lines, which means you have a right angle. And if you have a right angle, then it has to be an altitude. Make sense?
Okay, thank you. Yes.
Okay. Kylie, you ready, man? Did you do the constructions?
Yep.
All right, let's see if your constructions were correct. Kylie, your first construction was an altitude from P to RQ, correct?
Yeah.
Okay, so I'm rough sketching these. Realize I can't do constructions electronically, but you did this as a construction, correct? Kylie, you did this as a construction, correct?
Yeah.
Okay, let me try to do this as straight as possible. What can I use? I'm gonna use an envelope. All right, so this should look something like that. You got a right angle. And what is this point down here? Is that T?
It's J.
J, you're correct. Okay, so that's an altitude. You have an angle bisector. And the angle bisector, if I'm not mistaken, is this angle, correct?
Yes.
All right, so I'm going to draw that. I'm just rough sketching it, so I'm not sure how accurate it is. It's a bisector. What's this point out here?
H.
You are correct. H. And that is not a midpoint. Midpoint's not an H, but that is an angle bisector. GLE. That actually looked like a legitimate L. All right, what's the last one, ma'am?
A midpoint of PR.
Okay, and that gives what's that midpoint?
T.
T. And then you have a median, which connects vertex to midpoint. And very important, that does not bisect that angle at Q. It's very important. That's not an angle bisector. It's a median. Does that make sense, Kylie?
Yeah.
Okay, Kylie, you were given two angles. What were they?
P is 88 degrees. And
So the whole thing?
Yeah.
88. And what else?
R, the entire, is 64 degrees.
All right, 64, and that's it, correct?
Yes.
Okay, Kylie, why don't you start talking to me about what you can find?
Q.
What'd you get for Q?
I can do it right now.
Okay.
Q is 28.
You are correct. All right, what's something else you can find, Kylie?
The two bisects of R,
Would be what?
32 and 32.
Uh-huh. All right. Keep going. What else could you find?
Um,
Look what I'm highlighting. What do you have there, ma'am?
32 and 90.
Ah. Do you see what you can get?
$58.
Mm-hmm. Let me do another highlight and then I'm gonna cut you loose and let you find as much as you can on your own. Do you be really careful with these larger overlapping triangles? That's what tends to get overlooked. So talk to me, you see this red sweeping angle at H? Talk to me about how you would find that.
Wait, sorry.
Yes,
I'm a bit confused. How did you get the 58?
I'm so glad you asked that. Do you see that there's a right triangle here?
Oh, yeah.
Yeah.
Oh, I missed that.
Because of that word altitude, Ayush. And then where did the 32 come from?
That came from the angle bisector cutting
Correct.
off.
Yeah. So you add 32 and 90 and take it away from,
180.
you got it. All right. Kylie, talk to me about how you're going to find this angle out here.
Wait, is it 94?
Okay, let's pull that triangle out. Do you see the green triangle?
Yeah.
Got it. So down here on the left, what's the measure of that angle?
32.
I'm darkening it, 32. Okay, on the right, what's the measure here?
28.
28. So how could you find that red angle?
180 minus 160.
Bingo. Well, not 160.
Oh,
sweetheart,
I meant 60. I meant 60.
Okay, there you go. Oops. Let me go what you get there, Kylie.
120.
You are correct. So once again, you're just look for those larger overlapping triangles. So let me give you one here that gets overlooked. And then you're gonna have to figure out, see this is a larger overlapping right triangle. Do you see this big right triangle here, Kylie?
Yeah.
Okay, so now you could probably get this angle back here, correct? It's not 88. Do you see how to do it?
Yeah.
Okay. Hayden, glad you could join us. Hayden, what problem did you want to go over, sir? Hayden, what problem did you want to go over, sir? Hayden, talk to me, kiddo. You just jumped in. I'd like to say hello. What problem would you like to go over? Oh, fixing microphone. If you can't talk, Hayden, go ahead and text. Uh-oh. All right. Kylie, Ayush, London? Another problems?
For me, that was mostly the construction problems. And
Okay,
figuring
so
out all the angles.
yeah, constructions, I can't demo because I didn't bring my document camera, but did you see on YouTube? I already explained those.
Yeah, for me, the most hardest part is figuring out like the triangles and where they end and where like another one starts.
Okay, so did you do the constructions on this page already?
Yeah,
So you already did the constructions on this page?
uh-huh,
Okay, so have you been tracking with the angles that Kylie and I have been doing?
yeah.
All right, so on that note, let me just backtrack here. What would this orange angle be?
I got 62.
You're correct. All right, so I'd like you to trace the 88, trace the 62, and then talk to me about how you would find that green angle I just highlighted.
I got it by minusing 62 from 88.
And what'd you get?
26.
Uh-huh. Which, if you look carefully, this triangle right here is a right triangle, so you can add 26 and 64. 10, carry the 1, and it's 90 degrees, which we would expect because there's a 90 degrees here, so you know you're correct.
Uh-huh.
And then you could look, so you just keep looking for overlapping triangles. So here's another one. Do you see that triangle right there?
Yeah.
So this right here is 26. This one is 32. So now you can get the squiggle.
Mm-hmm.
Do you see it?
Yeah, I'm doing the math right now.
Yeah. Now it's important, Ayush, when I say find everything possible, it doesn't mean everything is possible.
Okay.
Then that's for you to figure out. Is there might be some angles that are honestly not possible. But I'm not going to
Okay.
tell you which ones are, which ones aren't.
Yeah, I got that big angle.
Mm-hmm.
I got 126.
Mm-hmm. And then you can get this angle over here, this green. You should already have the red.
I missed the red.
Okay. Do you understand how to get the red? Here, let me
No.
highlight it. You see, you got to look for these larger overlapping. I'm going to highlight it in green. See it?
Yeah.
So over in this corner is 32. Over in this corner is 28.
Oh, so I got it now.
Mm-hmm.
Oh, so that'll be 120. Oh, and then the angle.
Whoa, hang on. What is it?
120. That red angle.
Yes, 120. Got it. I thought you said 150. Yeah. Which means you can now get this angle right there.
Which is 60.
60. And now you can, again, just keep looking for overlapping triangles. See this orange triangle here? So now you can get this black squiggle.
Which would be 58.
Correct. Which makes sense because 58 is a vertical angle right across from it.
Well, and now I can figure out TP.
Yeah, you can get this angle because it's a linear pair. You just keep working. You look for linear pairs, you look for triangles, you look for vertical angles, you look for the right triangles, and just keep working it piece by piece.
Okay.
Miss Way,
Hi, yes,
will
London,
you
what's up?
be in your classroom tomorrow after school?
After school, no, I have a dentist appointment tomorrow. I'll be in there during open 1B and I'll happily be there at lunchtime, although I'm usually not available for tutoring on Tuesdays, but for you, I'll be there.
Okay, thank you.
So do you have open 1B, London?
Yes, I do.
Then I will be in my classroom by 7:40. If you want to come by, you're welcome to.
Okay,
Sound good?
okay, yeah, thank you.
You bet, sweetheart.
Okay, yeah, I think I can figure out the rest now.
Sounds good.
And that's all I had for today.
All
Thank
right,
you.
you sounds good.
Bye.
Take care. Kylie, how you doing, ma'am?
Good.
You got me all to yourself, kiddo. What would you like to do? And if you're good, that's totally fine. No obligation.
Can we go through number 5, please?
Mhm. That's this one?
Yeah.
Okay. Did you already graph these points?
Yeah.
Okay, let me graph them myself. So J, -4, +3. K is at 0, 1. Hi there, Hayden. Welcome back. Let's see, L is at 0, -3. Hayden, I'm on problem number 5. M is at -4, -1. So far we have this. Okay, Kylie, read out loud. What are you trying to prove?
Triangle JKL is congruent to triangle LMJ.
Okay, so JKL, if we trace it in, there it is right there. All right, Hayden, I'll come back to 4 in just a moment. So we're going to try to prove that these two triangles are what?
Congruent.
Okay, just to kind of get us to here, what are the 4 shortcuts for congruency?
Vertical angles.
It goes something, 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 comma, something, 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 comma, something, 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 comma, something, something, something. Shortcuts to congruency. There's 4 of them. It's related to sides and angles.
Oh. Side, side, side.
Uh-huh.
Side, angle, side. Angle, side, angle, 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 side.
Correct. Now, in this particular case, I want you to prove that this triangle, I'm going to highlight it for you, is congruent to this triangle, but I'm going to restrict you to using which equation?
Distance.
So distance equation, does that show the middle of something, the tilt of something, or the length of something?
The length.
You are correct. So if I found the length of JK and ML, and I found the length of MJ and KL, which of those 4 shortcuts do you think I would be proving?
Side, side, side.
Yes, because if I found the length of the blue and found them to be equal, that'd be side. If I found the length of the green and found them to be equal, side. Where would the third side come from? It's a freebie. I'm doing side, side, side. There's a third pair of sides. You don't even have to use the distance equation.
Reflexive property.
Yes, ma'am, which would be JL. And that'd be your third pair of sides.
Okay.
So how many times are you doing the distance equation?
3.
Careful, careful, watch. 1, 2, 3, 4. How many times are you
5.
doing the distance equation?
5.
No, 4, dear, because that
Oh.
red one down the middle is reflexive. You don't even have to find the distance. You just say JL is equal to JL.
Okay.
Make sense?
Yep.
Okay, previous. All right. Hayden, you got me all to yourself, sir. Take a look here. Hayden, why don't you go ahead and read the given out loud?
BAC isosceles with A as a vertex, angle BDC congruent to C angle CEB.
Great. I want you to take just these two pieces of information, just these two, and put it on the diagram.
All right. All right, got it.
You got those two pieces?
Yep.
Okay. Now, so far, this is what you kind of should have. If this is isosceles, you should have traced these two sides and marked these two sides equal. And I'm just going to
Yep.
circle A as the vertex. You okay so far?
Yep.
And then BDC, trace, sweep is congruent to CEB, trace, sweep. So those are your two pieces of given information. Are you okay so far?
Yeah.
Okay, what are we trying to prove? To prove just means explain.
That DC is congruent to EB.
Great, so I'm gonna squiggle that. I'm not gonna put a hatch mark because you're not told they're congruent. You're gonna have to prove somehow they're the same length.
There.
Now, I give you a hint how you're gonna do that. Can you read that first hint?
Trace and pull apart triangle DBC and triangle ECB.
And then what are we gonna show?
That DBC is equal to triangle ECB.
All right, so we're gonna trace these triangles and pull them apart. So DBC. Do you see what I'm doing here?
Yeah.
Got it? And
So I can just redraw those to the best of like my ability.
yeah, and kind of
Okay.
draw it to scale. Notice how I have like
Yeah.
one side a little bit longer than the other. Now, here's the important part. Now we're going to pull down. What do you know to be true about those triangles? Like you're
that
looking for things that are congruent.
BDC is congruent to CEB.
Yes, so we already know these two are congruent, so you mark them. When I pause, you say sides or angles. Right now we have a pair of.
Angles.
You are so correct. So I'm going to put 1A and circle it just so I keep track of it. Okay, so we're working ourselves through given, implied, freebies, and we're talking it through. So we are done with accounting for our given information. Now you're looking for what else has to be true because of the given or what might be a freebie. And to refresh your memory, freebies are things like vertical angles. If you see them, you can mark them. Or a reflexive side, that's a side that's shared exactly by two triangles.
All right.
So coming over here, remember I told you we started with 2 equal sides?
Yes.
If we have 2 equal sides, that implies we also have 2 equal angles. Where would
Yep.
your equal angles be?
Angle B and angle C.
Aha,
Right.
good
Yeah.
man, you're correct.
All right.
In the original, that would be like this.
Yeah.
Here, I'm going to pull it out. Because it's my second set, I'm going to go double hatch, double hatch. And that's a pair of angles. Remember, our goal is to get these triangles congruent. Because if the triangles are congruent, then the parts are congruent.
Yep.
Hi, Lonnie. I'm working on problem number 4, ma'am. Okay, so Hayden, you found the implied. Is there a freebie here? What else do you know is congruent? Look very carefully. I'm going to trace the original 2 triangles. Watch carefully. See that one?
Yeah.
See this one? What do you notice?
That like the top angle like between them would be actually
What do you notice?
that the bottom length would be equal on both of them.
Okay, what do we call that? They exactly share the same side. What do we call that?
I'm not sure.
Okay, when they exactly share the same side, that's called reflexive.
Okay.
So
I'll
that
write that
gets
down.
us a side. Now the question is, now you have enough information to say the triangles are congruent. Which shortcut is going on here? Remember, there's
A-
4 of them. How about this? Why don't
Yeah.
you just tell me what are the 4 shortcuts?
SAS, AAS, SAA, is that one? Side angle angle?
Yeah. Well, we usually say AAS, or SAA. Same thing. Yes, and
ASA, angle
SA.
side angle.
You are correct. Those are your 4 shortcuts. Which shortcut do you see is going on here?
Angle side angle, or is it?
Is
angle,
that
angle,
side squeezed between both angles? Or
No.
is it a tail of one?
A tail of one.
Okay, so which shortcut's going on here?
AAS, angles,
Okay.
angle side.
Angle side. You're correct. So if you were to do this, do you like to write sentences? Do you like webs? Do you like paragraphs? What do you like to do?
I have to write like sentences.
Okay, so sentence number 1 would be, do you see I'm going to number it for you? Why
Yeah.
are those angles congruent? Sentence 2 and 3, you have to talk about the isosceles and then the fact that those angles are congruent. Sentence 4, which sides are congruent and why? Sentence 5, you have to specifically name the triangles and say the whole's equal. And then sentence number 6, if the whole is equal, the parts are equal. So that's 6 sentences. And remember, every sentence must have you must cite the math. where does it come from? You have to go, what is congruent? Why is it congruent?
Yeah.
Sound good?
Sounds great. Thank
All
you.
righty. Lonnie, which problem did you want help with, ma'am? You'll be my last one.
Did you already do number 3?
But you've managed to chose the one problem I haven't done. Let's do it.
Cool.
Yeah.
Okay.
Everything else I've done practically. All right. Step number 1, we're going to walk ourselves through gift, given, implied, freebies, and talk through. So read the given out loud.
BC is congruent to EF
And?
AC is parallel to DF.
Excellent. And what are you trying to prove?
Angle BFC is congruent to angle EFC or ECF, sorry.
Great. Step number 1, all I want you to do, we're going to do this one little step at a time. All I want you to do is get this information on the diagram.
Okay.
So Lonnie, you should have gone like this, right?
Mm-hmm.
Hatch mark. Did you already put your S for sides?
No.
Okay, do
But-
you understand why we would put an S?
Because they're congruent.
Yes, ma'am. So right now, when I pause, you say sides or angles. Right now, we have a pair of
Sides.
bingo. Okay. Now I want you to get this information on the diagram.
Okay. Okay.
All right, take a look here. You should have always stretch out. You should have stretched out these parallel lines,
Mm-hmm.
and you should have little arrow feathers, not hatch marks.
Yeah.
Got it. So we are done with our given. Now we're working on implied and freebies. What else do you know must be congruent? Either it's because of the given or it's a freebie.
Uh, 1 and 2.
Okay, why would 1 and 2 be congruent? You are correct, but why?
Because armpits of the Z.
Good. Right now we have a pair of
Angles.
good man. Good dear. Got it. All right. Anything else you know has to be congruent between these two triangles? Between the yellow triangle and the orange triangle? Don't forget your freebies. Freebies, there's 2 freebies you want to watch out for. Vertical angles, if you see them, you can mark them.
Mm-hmm.
Also, if you have a side that's shared exactly between 2 triangles,
Oh, reflexive side.
which would
Is that
be
what it's called?
which one?
FC.
You are correct. Double hatch, and now that's a S.
Dot.
Yes. So why would the yellow triangle be congruent to the orange triangle now? Which
Because
shortcut is going on here?
side angle side.
Yeah, so at some point you have to say the triangles are congruent by side, angle, side. Does that make sense?
Mm-hmm.
All right, which 2 angles are we trying to explain are congruent?
BFC and ECF.
Squiggle those.
Okay.
All right, so you should have done these 2 guys.
Mm-hmm.
Got it? So your last step, you can say those are going to be equal Because if the entire triangle is equal, the yellow and the orange triangle is equal, then the parts are equal.
Okay.
That's your last step. Do you like to write sentences? Do you like to do webs? Do you like to do 2 columns?
I think I like the webs.
Okay. In this case, your web, you would start with your 2 pieces of given information like this. Got it?
Mm-hmm.
You understand? And then one of your givens gives you something else. And then that's something else, this, and then what we call a freebie, which is a standalone.
Mm-hmm.
All 3 of those are going to feed into a piece of information. So that's kind of how your web's going to look. And you do your what is going on in the box, what? And you do your why is this allowed between the arrows. Make sense?
Yeah.
Okay.
Okay, thank you.
Yeah, good job hanging out to the bitter end here.
Do you have office hours tomorrow or no?
Yes,
Because
ma'am. I'm here. I'm going to be open 1B
Mhm.
and I'll be there at lunch, but not after school.
Okay.
All right.
Okay, thank you.
My pleasure, dear. Bye.
Bye. Miss Way, I had one
Yes,
quick
ma'am.
question.
Yes, ma'am.
For the equation, I think it's number 9. I don't know how to read Roman numerals.
9 would there
Yes.
that? Uh-huh.
Yeah. Is the equation 5x plus x plus 90 equals 180?
Yes, ma'am.
Okay. And is x equal to 15?
Yes, ma'am.
Okay. Just making sure.
Good job.
All right. Thank you.
My pleasure. Bye now.
Bye.